In this video, we're going to work with complex numbers and vectors. We're going to start off by just doing some different things with complex numbers, powers, multiples, addition, subtraction, division, that kind of thing. So here we have j to the 91. I always break it up into two pieces. So here we have j to the 88 and j cubed. The reason for the 88, because this is a multiple of 4. Any multiple of 4 will be just 1. Then you have j cubed, which is going to be negative j. Or you could take it a step further, go j squared times j. J squared is negative 1, and then negative j. So our final answer is just negative j. Our second example here, we need to simplify all these roots. So we have 3 plus 6j, negative 2 minus 3j, and negative 6 minus 2j. We get rid of the brackets. And collect like terms, giving us negative 5 plus 5j. For our next example, we're multiplying. We can FOIL here. So we get 20, negative 12j, positive 35j, and negative 21j squared. So we have 20. We can combine these, giving us plus 23j. And then lastly, this negative 21 times j squared becomes plus 21. J squared is negative 1. Negative 1 times negative 21 makes positive 21. And we get 41 plus 23j. Now division, we need to do a multiple of the conjugate over the conjugate. Now if you remember, we did talk about conjugates a little bit when we were dealing with roots. It's the same idea. So we have 5 minus 4j and 5 minus 4j. Remember, it's whatever's in the denominator, but with a different sign. FOIL the top and FOIL the bottom. Collect like terms. Remember, j squared is negative 1, so we get negative 28 on the end. The bottom, j squared, we get positive 16. You'll notice there are now no more j's in the denominator, and that's why we use the conjugate. This ends up being break it up into the two pieces. And that's our final answer. You could convert it to a decimal, but it's just as easy to leave it in the fractions. Just remember to reduce your fraction. But here we have our real part, the negative 13 over 41, and our imaginary part, the 47 over 41j. All right, let's do some work in polar form. Now, with polar form, when we're multiplying, all we have to do is multiply the two radiuses together. So 6 times 8 equals 48. And then you add the angles together. So 70 plus 220 equals 290 degrees. Division, same idea. 15 over 3 is 5. And then 35 minus 120 degrees is negative 85 degrees. But we don't like the negative angle. We prefer an angle between 0 and 360. So all we have to do is add a full circle to get 5 angle 275 for our answer. When it comes to adding or subtracting polar form, there's a couple ways you can do it. The book often will show you to draw them out, draw the triangle, use sine law and cosine law. The other option is to break it down into your x and y components, add them, and then convert it back to polar. The easiest way to convert it back to break it down into components is just to put this into trig form. Multiply these out and add them up. So this is the answer in rectangular form. We just need to put it back into polar form. I always like to do a quick sketch. So we're negative 11.4 on the x and up 27.3 on the imaginary y, which puts us over here. We can calculate radius using Pythagorean theorem. So we get 29.6 for our length. Theta will be tan inverse of the imaginary y value over the x value, which is negative 67.3 degrees. But the negative 67.3 degrees would be down here. So we have to correct it by adding 180. There's a 180 difference. So we add 180 due to cast. Remember your cast rules. And this gives us 112.7 degrees. So put it all together. And your final answer is 29.6 at 112.7 degrees. Working with exponential is basically the same idea. Here we multiply the 2 by the 4 to get 8, and then we add the exponents. So 3/2 pi plus 3/4 pi is 9/4 pi j. You can just use your calculator to add fractions if you want. But 9 pi over 4 is bigger than 2 pi, so it's bigger than a full circle. We always want an answer between 0 and 360. So if we just subtract 2 pi, which is 360, we get a final answer of 8e to the pi over 4j. Division, same idea. 32 over 2 is 16. Subtract the two exponents, we get negative 3.35j. And same idea, if we add 2 pi to correct it, we get this for our final answer. Now, subtracting exponentials, the same idea as subtracting polar or adding polar. The easiest way is to put it into trig form. So we get 12 cos 0.8 plus j sine 0.8 minus 9 cos 6 plus j sine 6. Multiply these out. And you would get this answer in rectangular. This would be approximately right here. We can find r. We can find theta. The only thing is, again, that would be somewhere down here, so we need to do a correction of adding 180. And again, this is due to the cast rule. So we get a final answer of 11.1 e to the 1.596 j. Now the biggest thing when doing this is be very careful and make sure your calculator is in radians. Now let's look at some vectors. Now vectors and complex numbers have a lot of similarities, and sometimes some people will use a complex number to represent a vector. There are some differences though. So vectors come only in rectangular and polar. They do not have exponential or trig. The other thing is you can only add or subtract a vector or multiply by a scalar. You cannot multiply or divide two vectors together. The conversion is basically the same idea. So here we have a vector, which is negative 10, 8, so somewhere over here. We can find the length, or the radius, just using Pythagorean theorem. Which in this case is 12.8. We can find the angle using tan inverse. 8 over negative 10 gives us negative 38.7 degrees. But again, this one ended up over here, so again we have to correct it by adding 180 for cast rule. So we get an angle of 141.3 degrees. Now, you're not always going to have to add 180, but it happens enough. So you should always draw it out. That's why I always draw these sketches, to make sure I know to use the cast rule in the appropriate spots. So here our vector is 12.8 at an angle of 141.3 degrees. Now to convert back from polar to rectangular, you can just break it down into its components. Again, it's basically the same idea as using trig rule, but we have x equals r cos theta and y equals r sine theta. And this will give us negative 12.0 and negative 35.0, so our vector is negative 12, negative 35 in rectangular form. So we have an x component of negative 12 and a y component of negative 35. Now here we have 4 times the vector 5, 25. The 4 is what we call a scalar. So all we're doing is increasing the length. We're not changing the direction. So this is just become vector 20, 25. Now the next one, we have absolute value bars of a vector. When you see these, it actually means what is the magnitude of the vector. So all we actually care about is the magnitude or the length. We do not care about the direction. It's basically saying find r. So all you have to do is Pythagorean theorem. And in this case, we get 17.7. When you are finding the magnitude of a vector in polar form, all you have to do is read it. You don't have to do any calculations at all. Adding and subtracting vectors in rectangular form is quite easy. You just add the x components, so negative 6 plus 8 is 2, and then you add the y components. 11 plus negative 3 is 8. There's our final answer. In the second example here, we have scalars and then subtracting. Well, deal with the scalars first. This becomes vector 30, negative 10. We just multiplied the 5 by both the x and the y. And then we multiply the 3 in the same way. So we get negative 6, 21. You could have also multiplied the negative 3 in, making it vector addition. Just make sure to change the signs on both the x and the y. Now for subtraction, we have 30 minus negative 6 is 36. Negative 10 minus 21 is negative 31. Adding and subtracting vectors in polar form is a little bit more complicated. You could draw them out, make a triangle, and use sine law and cosine law, or we already know from complex numbers that you can do all this using the components. So x is going to be made up of the components of each, so 18 cos 64 and 22 cos 131, which gives us negative 6.543. The y, same idea, 18 sine 64 plus 22 sine 131, which is 32.782. From there, I always like to draw it out for -6 up 32. So we're in that quadrant again. We're going to figure out r just using Pythagorean theorem again. So two squared, and we get 33.4. We can figure out theta using tan inverse. Again, we're going to have to use the cast rule and add 180. So we get a final vector of 33.4 at 101.3 degrees. Subtraction, same idea. Find your x and your y. So 56 cos 213 minus 42 cos 307, which is -72.242. Same idea for y. Which is 3.043. So in this case, it's somewhere over here. We can calculate r. We can calculate theta. Which is -2.4 degrees. But again, just by the luck of the numbers I picked, we end up having to add 180 for cast again. 177.6. So our final vector is 72.3 at 177.6 degrees. Vectors are used in a ton of applications. We use them all the time in physics for forces. We can use them for electronics. We can use them for velocities. But the biggest place you will see them is physics. Now this first example, we have an object on a ramp and we need to know how much force to move it up. So let's draw it out. So we have a ramp. We have 15 degrees. So obviously it's not to scale. We have an object on the ramp that we're trying to move up. Right now we know the force on the object is gravity, pulling it down. Force of gravity is mass times acceleration. So 125 kilograms times 9.81 for gravity gives us 1,226.25 newtons of force straight down. We need to break the gravity up into two pieces, a part parallel to the ramp and a part perpendicular to the ramp. You also have what they call the force normal acting on the object. I don't really test on that though, but you will see it in physics. The way we've set it up, our 15 degrees is also the angle inside this triangle, and we need to figure out this force here. So we can just use sine. So sine 15 degrees is equal to that force we want over the force of gravity. So we end up getting force of 317.4 newtons to move that object up the ramp. Basically, the force of gravity parallel to the ramp is 317.4 newtons in this direction here. We just need to break that by an equal or greater amount to pull it up. Here's another force problem. So we have 225 newtons and we have 180 newtons acting on an object with an angle of 120 degrees between them. Now you could move the 180 newtons over, so you end up with 225 and 180 with your angle here to get your resultant vector. and figure that out. But when we're just going to use components, it's just as easy to turn this into the force vector of 225, set it at angle 0, plus the force vector of 180 at 120 degrees. We can find the components of each. And then find R, which is 206.2 newtons. And that's all we need in this case, because all this one asked was the magnitude, so we don't care about the direction. If we did ask for the direction, we'd have to state whether it was with respect to the 225 or the 180. Usually we go with the larger one. But in this case, all we cared about was the magnitude, so we can stop with our answer of 206 newtons. One last example for this video. This one's a velocity vector problem. So let's draw out our basic compass. We have north, east, south, and west. Now, we have the plane going north, 32 degrees towards the east. So the plane is doing something like this at 340 kilometers an hour. We have 32 degrees here. And then we have the wind, 45 kilometers an hour south, 80 degrees west. So south, 80 degrees west. This would be your 80 degrees, 45 kilometers an hour. And again, you could move this around and try and figure it out using trig. So you'd put your 45 kilometers an hour here, and then this would be your resultant. But we can just break it up into each. So we have the velocity vector 340 at 58 degrees, and we have the velocity vector of 45 at 190 degrees. Now you might be asking where these are coming from. The 58 is this angle, and this is 190. So you have to adjust them so that you use this is east is your 0 reference point. From there, we do our same idea. Find your x and y components. So x is 340 cos 58 plus 45 cos 190, which is 135,856. And then your y, which is 280.522. Find your r, giving us 311.7. Find your theta, which is 64.2 degrees. Now 64.2 is here, but to get our heading, we're going to need to do this angle, which is 25.8 degrees. So our final answer is 311.7 kilometers an hour at north, 25.8 degrees east. So when you're doing a heading, it's always either north or south first, and then it's so many degrees towards east or west. And your degrees east or west should always be less than 90. And this is our final answer, you'll notice the wind has slowed the plane down and shifted it off course about 6 degrees.